Hi, I'm going to give you a really brief introduction to using JAX on CoCalc. So as you can see at the JAX Quickstart, JAX is like NumPy, but it runs on a GPU and it has support for automatic differentiation so that you can implement machine learning algorithms, like neural network type of algorithms on top of JAX. So it's kind of like an alternative to PyTorch or TensorFlow with a more declarative feel. So I'm just going to show you how to use JAX with the GPU on CoCalc. So the first thing we'll do is sign into CoCalc, and then we'll open a CoCalc project. I have one here called demo that doesn't have anything in it. Since we're going to be running code on a GPU using JAX, we're going to create a compute server. Since the default projects inside of CoCalc, they have fairly limited compute power, they don't have GPUs, and they don't even have a full installation of JAX. Whereas with a compute server, we do get all of that. So click on servers, click create compute server, and then we'll call it JAX. And we need a GPU. And let's make sure it's a standard instance. We don't have any issues with availability or with the server shutting down while we're working. And we can use either a T4, L4, or A100 GPU. So for this demo, let's just use a T4 GPU because we're just going to do some very basic JAX work. Next, under image, let's choose the JAX image here at the bottom. And there's some links to JAX and some information about it. Everything else should be fine. Don't think we need to change anything at all. So let's just start our server running. And here it goes. So this is firing up a machine with a virtual machine with a T4 GPU on Google Cloud. It will then connect that virtual machine to CoCalc and allow us to run Jupyter notebooks on it. So just wait a little while for it to start up. While we're at it, let's look at this quick start. We're going to want to download the IPyNB file. And you can do that by just clicking there. This gives us a direct URL to the IPyNB file, which we'll copy and paste into our CoCalc project while we're waiting for the machine to be ready. So I'll just click new and then paste the URL in and then have it download the file. And there we are. There's our quick start. We can just open this. It shouldn't work yet because we don't have our GPU and we don't have JAX installed. So if I try this first line, I should get an error because, well, okay, so there is some version of JAX available just without a GPU. I wonder, how can you tell with JAX whether or not a GPU is available? JAX GPU available. How to detect if a GPU is being used? And here's what you do in 2019. Let's see what happens. Cool, it says it's using a CPU. So let's see how our compute server is doing. Looks like it's almost ready. It's 80% ready. So we just have to wait a little bit for this kernel to launch. Okay, boom. This Docker container is completely started up. We now have a GPU with the JAX image. By the way, this JAX image is exactly the one that's hosted on the NVIDIA website. It's a very complete image that's provided by the JAX developers. So you could just directly use JAX, as you can see here, on the CPU in CoCalc without even messing with the compute server. But since we want a little bit of extra speed, let's use the compute server, which has a GPU. So we switch to the compute server, which has the GPU, connect to it, and now again, let's start up JAX. And now let's see, does it have access to the GPU? And the answer is yes. We have access to our GPU, which is great. By the way, if you want a terminal, you can go plus new Linux terminal. We can set it to run on the compute server. And this is nice if we want to run top, or if we want to see using the NVIDIA SMI command that we actually have a Tesla T4, how much memory is being used, etc. Okay, so let's try out JAX. So we'll create a matrix. It's really big. And let's multiply. So it runs on the GPU. And you can see this is presumably very fast. Now I obviously am extremely tempted to make a copy of this notebook and run it on the CPU and see how the speed compares. And to do that, do File, Duplicate, and then I'll say -CPU, duplicate item. And now right next to my notebook that's running on the compute server, see it's purple and it has that line across the top saying it's running on the compute server at the GPU. I have this one that's just running on the normal default shared resources. So let's just go through, run the same thing, and then see what the timings are like there. So this one on the GPU, it was 13.7 milliseconds. And on the CPU, it's taken a while. Notice the CPU is burning. It's taken a long time. And there it is, 1.14 seconds. So that's a huge difference. 100 times slower. And then let's try this one. So you can see that the GPU absolutely massively speeds things up. So 827 instead of about 30 milliseconds. All right, let's switch back to the GPU. And you can just go through this and try out everything and study it. And you can see that it's working. And that's where I'll leave you. So go to the JAX documentation, try out anything they have there. You just look at it. By the way, there's a little goofy thing. If you try to move your mouse to the extension and click, it always goes away instantly. You have to click on the download button, then the menu persists, and then you can click to download the source file.